Welcome to Mastering Solutions. So let's start drawing our picture, and we'll place the object, which they say is 4 meters away from this diverging mirror. The focal length for this is half the distance. And remember, for a diverging mirror or a convex mirror, that focal point is always on the opposite side over here. So it's going to be half this distance, so about like this would be the focal point for this diverging or convex mirror. And to draw the ray tracing, we're going to do the 3 special rays as the book talks about, or remember, parallel to the focal point, the center of the mirror or center of the lens, and then the focal point to parallel. And so we'll start off with the parallel, and then it's going to reflect, and how much it reflects is as if it was coming from the focal point, and then it will go out like that. Now we are going to go center of the mirror, and since this is the law of reflection, it's going to reflect at the exact same angle as the angle of incidence, so about like this, and it will extrapolate out like that. And now we're going to go through the focal point. And anytime you have light going to the focal point, it will be reflected or refracted parallel. And so we have this coming out right here. And so you can see that we get a virtual and an upright image. So it's upright and virtual. And just like with diverging lenses, all images on a diverging or a concave mirror are going to be virtual, which means they're all going to be upright. And you can see how we drew the ray tracing that we also got some minification, meaning the image is smaller than the object. And that makes sense if you've ever seen a convex mirror in like a store or something like that. You look smaller when you look into it. And we just proved that with our ray diagram. Now let's find the location of the image, and we didn't do it with our diagram. You could have, but let's use the thin lens formula to solve the image distance. So 1 over f is equal to 1 over s plus 1 over s prime. We're trying to solve for the image distance, so we'll isolate 1 over s prime. So 1 over s prime is equal to 1 over the focal length minus 1 over the object distance. So 1 over the image distance is 1 over the focal length. And by convention, for a diverging or a concave mirror, it's always going to be negative. So negative 2 meters. And we're going to minus 1 over the object distance, which in this case is positive by convention. And so that's going to be 4 meters. So 1 divided by a negative 2 minus 1 divided by 4 gives us negative 0.7, and this is in diopters. And so we need to take the inverse of that answer, which will give us a negative 1.33 meters. And so the image will form at 1.3 meters from this diverging or concave mirror.